Welcome to this presentation. Today we are going to see about Dbmrp. The Distance Vector Multicast Routing Protocol is the extension of the Routing Information Protocol which is used in unicast routing. It uses the source-based tree approach to multicasting. It is worth mentioning that each router in this protocol that requires a multicast packet to be forwarded implicitly creates a source-based multicast tree in 3 steps. Now let's see one by one. The first one is reverse path forwarding. RPF is a modified flooding strategy to prevent loops. Only one copy is forwarded and the other copies are dropped. In RPF, a router forwards only the copy that has traveled the shortest path from the source to the router. To find this copy, RPF uses the unicast routing table. The router receives a packet and extracts the source address. It consults its unicast routing table as though it wants to send a packet to the source address. The routing table tells the router the next hop. If the multicast packet has just come from the hop defined in the table, the packet has traveled the shortest path from the source to the router because the shortest path is reciprocal in unicast distance vector routing protocols. So if the path from A to B is the shortest, then it is also the shortest from B to A. The router forwards the packet if it has traveled from the shortest path. It discards it otherwise. So this strategy prevents loops because there is always one shortest path from the source to the router. So if a packet leaves the router and come back again, it has not traveled the shortest path. So to make it clear, now let's see an example. That is the shortest path tree as calculated by routers R1, R2, R3 can be shown as a thick line. When R1 receives a packet from the source through the interface M1, it consults its routing table and finds the shortest path from R1 to the source through interface M1. Now the packet is forwarded. However, if a copy of the packet is arrived through interface M2, it is discarded because M2 doesn't define the shortest path from R1 to source. So the story is same with R2 and R3, and you may now wonder what happens if a copy of a packet that arrives at the M1 interface of R3 travels through R5, R2, R6, R5, R2 and then enters R3 through interface M1. So the interface is the correct interface for R3. So is the copy of the packet forwarded? The answer is that this scenario never happens because when the packet goes from R5 to R2, it will be discarded by R2 and never reaches R3. So the upstream routers toward the source will always discard a packet that has gone through shortest path, thus preventing confusion from the downstream routers. And now let's move on to next category called reverse path forwarding. RPF guarantees that each network receives a copy of the multicast packet without formation of loops. So however, RPF doesn't guarantee that each network receives only one copy. A network may receive 2 or more copies. The reason is that RPF is not based on the destination address. Forwarding is based on the source address. So to visualize this problem, now let's take an example. Net 3 receives 2 copies of the packet even though each router just sends out one copy from each interface. So there is duplication because a tree has not been made. Instead of a tree, we have a graph, and net 3 has 2 parents called routers R2 and R4. So to eliminate duplication, we must define only one parent router for each network. And we must have this restriction: a network can receive a multicast packet from a particular source only through a designated parent router. Now the policy is clear. For each source, the router sends the packet only out of those interfaces for which it is the designated parent. This policy is called reverse path forwarding. RPB guarantees that the packet reaches every network and that every network receives only one copy. And now we can see the difference. We can ask how the designated parent is determined. So the designated parent router can be the router with the shortest path to the source, because routers periodically send updating packets to each other. They can easily determine which router in the neighborhood has the shortest path to the source. So if more than one router qualifies, the router with the smallest IP address is selected. And now let us move on to RPM, that is reverse path multicasting. And as you may have noticed, RPP doesn't multicast the packet, it just broadcasts it. This is not efficient. To increase the efficiency, the multicast packet must reach only those networks that have active members for that particular group. And this is called reverse path multicasting. To convert broadcasting to multicasting, the protocol uses two procedures, pruning and grafting. Now let's see the idea of pruning and grafting. The designated parent router of each network is responsible for holding the membership information, and this is done in IGMP protocol, and the process starts when a router connected to a network finds that there is no interest in a multicast packet. Then the router sends a prune message to the upstream router so that it can exclude the corresponding interface. That is, the upstream router can stop sending multicast messages for this group through that interface. Now, if this router receives prune messages from all downstream routers, then which in turn sends a prune message to its upstream router. What if a leaf router, that is a router at the bottom of the tree, has sent a prune message but suddenly realizes through IGMP that one of its network is again interested in receiving the multicast packet? Then it can send a graft message. So the graft message forces the upstream router to resume sending the multicast messages. Now let's move on to Dbmrp, that is distance vector multicast protocol, which is an implementation of multicast distance vector routing. It is a source based routing protocol based on RIP. And the CBT, that is the core based tree protocol, is a group shared protocol that uses a core as the root of the tree. The autonomous system is divided